Same lab, only the configuration AS value will change. So let's see, we can use the same lab to do this one. I have the configuration, I think before what we done. We can copy the same configuration and we can create the new notepad and we can paste here, and here it should be different number. AS, here I am using the AS1. Here we should have something different because we are doing EBGP, not the IBGP. So here I will take the 2, and same topology whatever we done in our previous class. I have one LAN network here, 1.1.1. Here is 2.2.2. We are taking the loop back. AS number for R1 we have the 1, AS number for R2 we have the 2, and in between the network we are using 192.168.12.0. So this one already we know, right? We already done in our previous class. Same topology we are using, only AS number is different here. So here what I will do, I will write here EBGP, and this configuration till here remains same. And here if you see, I am standing here, I am configuring the neighbor. So manually we need to configure some neighbor IP is same thing, 192.168.12.2. AS number will be 2. Now we change the 2. So when we have the different AS, then only it will form as a EBGP. So here our AS is 1, our neighbor AS is 2. And network command, we are going to use the same network command, that is like network. What command we have here? We have the 1.1.1/8. So we need to write the network ID of that one, and the mask, and the whatever subnet mask value we have, we will write that one. So this is the R1 configuration. Then for R2 also same thing. First we need to assign the IP as we done before. This is the basic configuration we are doing from long time. The real configuration will start here. Router BGP, you have AS number is 2 here. You are in the router 2. So you will change here as a 2, and then neighbor 192.168.12. Here what is the neighbor IP here? Here we configure 12.1. Here we configure 12.2. So here will be 12.1. So now what we will do, we will configure here neighbor 192.168.12.1 remote AS1. So here we will give as a remote AS1. Then we need to advertise this one, our local network, that is LAN network. So we write network 2.0.0.0 mask, and whatever subnet mask we have, we will write. We have /8 is nothing but 255.0.0.0. So what you need to remember here, whatever IP you have, you need to calculate the network ID. Here we are using the /8. So network ID of that will be 2.0.0 and mask, then write the subnet mask 255.0.0. That's all. This is the BGP configuration. This one we can say EBGP because we have the different AS. Here is 2, here is 1. Here is 1, here is 2. Okay. So now let's copy paste this configuration in the router and we can verify. So I will go here and we can take this CLI of the router, and maybe we will have the old configuration. Let's verify. No, here we don't have any configuration. This is a brand new router. Okay, so we can do the configuration. So these both routers are the brand new router. So we will do the configuration here. So let's copy the R1 configuration from here to here, and let me copy this one, and I will go here. I will paste here. Okay, and now I will copy the R2 also here, and I will go to the R2. I am going to paste here also, and let me press enter, and you can see now what we are getting. We will have the neighborship. We need to wait for some time, then we will get the routing table. We will have the route from the BGP. So BGP is a slow protocol, so we need to wait for some time, and then we need to verify that one. So if you see here what we are getting here, let's see. I will write how we can check the routing table. We will write show IP route. If you want to filter BGP, you can write show IP route BGP. Still we don't have any BGP routes here. That's why the routing table, if you see here, nothing is mentioned here. If you write without BGP, directly connected information will appear here. Okay, so it will take some time still, because BGP is going to what we can say, they are going to have the three-way handshake TCP session they will create. After that BGP will established. So we need to wait for some time and then we will see. Here if you see, you have the BGP now. I am in the R1, router R1, and if you see, we have the B here. B stands for BGP. You can see here B stands for BGP, and we are learning this network 2.0.0./8. So this network is coming from the R2 in the R1, and AD value you are getting is 20. Why we are getting 20? Because if you remember, we told like whenever we have the eBGP, AD value will be 20, and whenever we have the iBGP, AD value will be 200. So yesterday we checked, we are getting the 200 because yesterday lab we done the iBGP. Now we done the eBGP, so we are getting the 20, and this is the next hop, and from this much time this route is up. Okay, so this one is a BGP table. What we have, this is a routing table. We can say this one is a routing table. We can write show IP route to get the information. So we can say this is a routing table, and then we can check the neighbor table. How we can check the neighbor table? We can write show IP BGP summary. So when we write the show IP BGP summary, we will get the neighbor table. This contains the list of all configure BGP neighbor. In this one, all the BGP configure neighbor information will be available. This is we are calling as a neighbor table. We can write show IP BGP summary. With this one, we are going to get the list of all configure BGP neighbor. And in this one, what you are getting, if you see here, BGP router identifier, that is nothing but router ID. I am inside the R1. If you see, I am inside the R1, I am getting the router ID 1.1.1. And if you see, local AS is 1. So I am getting here what is our AS, R1 AS. Local AS means R1 AS, because we are inside the R1. So R1 is a local for us. So R1 local AS is 1. And if you see here, BGP version 3, BGP table version 3 is written here, and main routing table version is 3. And if you see here, this is a neighbor IP. This is the IP version which we are using. We are using IP version 4. That information is here, and AS number is 2, and how many messages receive, how many messages we send, and the BGP table version. This is a table version. Whenever we are changing anything in the BGP, if you are getting any update, this number is going to increment. So now you have 3. If I make any interface down, some route will go down, then it will become 4. Then again that route come up, it will become 5. Like this it will increment. So what I can do here, I can go here, I can say here interface loopback 0. Okay, because we are using the loopback right here in the R2. If you see, we have loopback 0. So what I will do, I will make this loopback 0 as shut. So this interface go down. Okay, and the route will remove from the routing table. And after that, when I write show IP BGP summary, you have here BGP version table is 3. It will change to 4. If you see, this is a BGP table version is 4, and main routing table version is 4. Both are same only. Whenever you have any changes, this number will increment. If you have any new routes, if the routes gone, if your new routes come, this will increment +1 +1 +1. So now both are same only. This one also, whenever we have any changes in the BGP table, any routes are coming or going from the BGP, you will have the increment of this number. This is also same thing, be a table version and main routing table version or BGP table version, all are same only. So now it increase. Now again I will write here no shut. Then again if you see, this number will change. You have 4, it will become 5. Here you have 4, right? So you need to wait for some time, and after that when you check here, you will have 5 here. If you see here, before you have 4 here, but now if you see, this one is 5. Okay, so this is the what we can say BGP routing identifier is this one, that is a router ID. BGP table version is 5, and here this is a neighbor information, neighbor IP, and whatever the IP address we are using, IPv4, IPv6, and this is a neighbor AS number, how many messages we receive, how many messages we send, and what is the table version, and how many packets we have in the queue in and out, and this much time this neighbor is up, and how many prefix we are learning. So this one we are going to discuss in detail in the coming classes. Now just I am giving you overview about this one. So what you learn here, you learn how to check the which table we say neighbor table. How to check the neighbor table we discuss here. And here you already know, just now as I told, this is a router ID, and what we can say, this is a neighbor information. So this is the what we can say basic lab for Ebgp we have here. And what else we can see the forwarding table also. So I can write here show IP BGP. This one is called as a forwarding table. This table contains the list of the network along with the path and attribute which are known by the BGP. So here when I write show IP BGP, you will get the forwarding table. In this one also, how you can read, this is a router ID, this one. Okay, we did not assign the router ID. By default the router taken. Later we are going to learn how we can configure the router ID in the BGP also. Now just remember, when I write show IP BGP, you will get the forwarding table. In that one you can get, first thing is a router ID here, and you need to see this one. If you are getting the star means valid, if you are getting greater than symbol means best. These two things you will have here. If you get star means valid, if you get greater than symbol means best. So if you see here what we are getting in the forwarding table, when I write show IP BGP, you are getting here star and greater than symbol for this network. Okay, this network learned by the R2 R1 our router, and here it is giving star and greater than symbol, means it is best and valid route. Here also you have star and greater than symbol, we can say this is a best and valid. So this route, if you get next hop as 0.0.0 means this is connected to us, this is locally, means this connected to our router itself only. If you are getting the next hop as a 0.0.0, we can say this network is directly connected to R1 only. Then if you check the another one, you have next hop. So this is coming from this router ID. From this router you are learning this network, and you have here the attribute. Later we are going to discuss attribute in detail. So now we have attribute metric, we have the local preference, we have the weight. Here if you see metric is 0, local preference nothing is there, weight is there 32768, and we have the path. So this one we are going to discuss in the coming classes. We have the attribute here in the BGP. We are going to manipulate the attribute depending upon the what we can say, taking the different ACL or access list or the route map. We are going to manipulate the traffic by playing with this attribute. So how we can read this one, same thing as we discussed before. We can say here this is a BGP table version, just now what we discussed, and then this is a router ID, and after that what we can say this one is a network, whatever network we are learning, and star means valid, greater than means best, next hop means from where you are learning this one, 0.0.0 means that this network originated on this router, that is the R1 only. If you see this one, and what we can say metric is nothing but BGP attribute. This one metric is a BGP attribute that are used to select the best path. In the coming classes we are going to manipulate this attribute. And we have the local preference. Local preference is also BGP attribute that we are going to use to select the best path, and weight is also BGP attribute that are going to use to select the best path. So we are going to see this one in the coming classes. We are going to play with this attribute to change the path. And we have the path here. It is a sequence of autonomous system in the path from left to right. So here we will have the different autonomous system. So depending upon that one also we can manipulate the manipulate the traffic. So we are going to use the attribute to manipulate the traffic. So what table we have here? We have three tables here. One is, this is a forwarding table, this is a neighbor table. Where is the neighbor table? Let's see. This is a neighbor table, this is a forwarding table, and we have the routing table. Where is the routing table? This one is the routing table. So these are the three tables available in the BGP, and this is a router ID. We did not configure router ID, router taken automatically the router ID. and after that we have the BGP state. So BGP state we are going to discuss in our next class. Now what you need to remember, how to configure the BGP and what are the configuration we done here in the eBGP, and also we can verify like TTL value. We are saying here we have one only, so we can check that also TTL value. Like in our previous class, if you remember, we checked the TTL value, we are getting the 255, right? I hope you remember that one, 255 we are getting. So now what we can do, we can write the what command we use in our previous class. We can use similar. Let me check here. I think we use the show BGP. I think show IP BGP neighbor. I use show IP BGP neighbor, and we can press enter and check here TTL value. You will get here, if you see TTL value we are getting as a 1. So you need to remember, whenever we are configuring the iBGP, you will get the TTL value is 1. Sorry, whenever you are configuring the eBGP, you are getting the TTL value is 1. Whenever you are configuring the iBGP, let me write here iBGP, you have 255. eBGP you have 1. So this one you need to remember. iBGP means 255, eBGP means 1. You are getting, we verify here. Before, if you remember, in our old lab you have 255 here. So now in this class what we learn, how we can configure, and we have this table, 3 table: BGP neighbor table, BGP forwarding table, BGP routing table. These 3 things we learn in our this class. So let me stop this recording.